talked about how they're made, how the polymers are made, and how the polymers are broken down. They're made by dehydration synthesis. They're broken down by hydrolysis. We talked about the 4 macromolecules, the proteins, the carbohydrates, the lipids, and the nucleic acids. And we also said that only 3 of them are made from monomers. The carbohydrates, which we already talked about. The proteins, which we will talk about. The nucleic acids, hopefully we'll get to it. And now this one is not made from monomers, lipids. Lipids are fats. Lipids are your hydrocarbons. And we talked about it in the previous chapter, chapter 4. Hydrocarbons are hydrophobic or philic? Hydrophobic, because they are polar or non-polar? Non-polar, yeah. So this is an example of a lipid. The fat, it's called a triglyceride. Watch this, tri means 3 fatty acids attached to a glycerol, which is an alcohol. That's why it's called a triglyceride. Or it can also be called triacylglycerol. These are 3 fatty acids. This is the hydrocarbon. This is the one that's nonpolar, the one that's hydrophobic. So is this one. So is this one. This is actually an alcohol, glycerol. Now watch. The glycerol has 3 functional groups. What is the name of this functional group? I warned you about it on Monday. What is the name of this functional group? The hydroxyl. Hydroxyl, very good. What is the name of this functional group? The carboxyl, very good. So look at this. I give you an analogy to a lot of things. Hopefully this works for you. This is like a coat hanger. A coat hanger with 3 hooks. The hook is the OH. There's another one. There's a third one. That means, how many coats can you maximally attach to that coat hanger? 3 maximum. I'm not saying you have to have 3. I'm saying the maximum is 3. Okay? What if you buy 5 coats? Now what?
You can only use 3.
What's going to happen to the other 2 coats? Don't say sell them. You need another coat hanger. You see that? So for example, let's say you eat 1 hamburger. Okay, you'll have 3 fatty acids. You'll be able to store it on this coat hanger. What if you eat 2? Then you need more of these. You need more coat hangers. And then you're going to gain weight, and then you're going to regret it later, right? Because that's how we store our fat. So the maximum occupancy on a glycerol is 3 fatty acids. Sometimes you'll have only 1 attached to it, and that's called a monoglyceride. Sometimes you can have 2. That's called a diglyceride. But eventually, if you keep eating and you need the storage, you'll eventually have a triglyceride. That means you have 3. If you have another fatty acid, then you need another glycerol for storage. Okay? How do you take the coat and hang it on the hanger like that? That's a chemical reaction. Dehydration. It's the same thing. But in this case, it's to get the fatty acid to attach to the glycerol. So, the hydrogen from the OH, the hydroxyl from the carboxyl group, you lose it as water. Dehydration. And this carbon no longer is happy, and this oxygen is no longer happy. They make a deal. Hey, let's share electrons, okay? Yeah, let's do it. And then they produce this. They produce a new bond. It's called an ester linkage. So it is a covalent bond, but it has the name ester linkage. In the monosaccharides attaching to each other, that was a glycosidic bond. Watch, glyco. Glyco means sugar. So when we were talking about sugar, Carbohydrate means sugar. Saccharide means sugar. The word glyco means sugar. OSE at the end of the word means sugar. How many ways can you name sugar? Those are the ways. OSE is sugar. So the name of the bond here is ester. The type of bond is also covalent. How was it made? Dehydration. Same thing. So now you can have 3 fatty acids attached. Now watch this. How many dehydration reactions occurred to produce a triglyceride? 3 of them. A dehydration reaction here, a dehydration reaction here, and a dehydration reaction here. 3 of them. How many dehydration reactions will occur when you make a diglyceride? 2. You see that? What about a monoglyceride? 1. Okay, so this is a type of lipid. Unfortunately, this is how we store our fat. Now, there are 2 kinds of fat. There's one that is healthier for you, and there's one that's not so healthy for you. The saturated fats are not good for you. Why? Because I tell students like this, if it looks like this on your plate, can you imagine what it looks like in your blood vessels? You see? You don't want that because it will give you a higher risk of cardiovascular disease and stroke and so forth. So, you don't want to consume a lot of this here. It is not healthy for you, saturated fats. Now the idea is that, why is it called saturated? Because there are no double bonds in the fatty acid. Look at it. They're all single bonds. That means they are saturated, or they are full of single bonds. Unsaturated fatty acid has at least 1 double bond. Look at it, a double bond, at least 1. Maybe more, but at least 1. And it's that slight difference that makes this liquid and this not. That makes this one a little healthier than this one, especially olive oil. The Mediterranean diet, like they say, right? The idea now is, why is this liquid? Because watch. This one is critical for the cell membrane chapter. Once you put a double bond, look what happens to the fatty acid chain. It bends. And when it bends, there's going to be less hydrophobic interactions between the fatty acid compared to this guy. See, this guy has a lot of hydrophobic interactions between the fatty acids. And that's why it looks like this. The reason butter looks like this is because it has a tremendous amount of hydrophobic interactions between the fatty acids. Why? Because the fatty acid is linear. It's linear. And the other one is linear. So there's a lot of hydrophobic interactions between them. Compared to this one of them is linear, but the other one is bent. So there's less hydrophobic interactions. That's why it's liquid. Very, very good, awesome questions on the exam and quiz. I'll tell you why, because if you don't understand that, you're going to have a lot of trouble with something called membrane fluidity in chapter 7. So please understand that the saturated fatty acid will have a lot of hydrophobic interactions, and that will look like this. The unsaturated fatty acid, because of the double bond, there's a kink or a bend enough to reduce the number of hydrophobic interactions, making it liquid, making it a healthier option for you. All right, the other kind of lipid, another one, very important. Again, it plays a role in chapters 5 and 7 and on and on and on and on. This is your cell membrane. This is the main lipid in your cell membrane. It's called the phospholipid. This guy, look at it carefully. It looks like a triglyceride. Remember the coat hanger? Here it is, glycerol. With one fatty acid that is saturated, another fatty acid that they happen to draw that is unsaturated. Why? Because it has a double bond, and because of that, it has a kink. You see that? This is saturated fatty acid. They happen to draw an unsaturated fatty acid, but watch this. The third coat hanger does not have a coat attached to it, because that would make it a triglyceride. No, it has a phosphate group and a choline attached to it. Now it's called a phospholipid. A phospholipid. This is your cell membrane. All membranes are made up of phospholipids. Not only that, look at it carefully, please. It's bilayered. It's not just one row of phospholipids, one after the other, after the other, after the other. No, it's two rows. And one is like this, and the other one is the other way. So it will look like this. I mean, I love these markers. Look, here's the phospholipid. There it is. There's water out here. Outside of the cell, there's water. And there's water inside of the cell. So when the membrane forms, there's only one option, is to do this. Why? Because this is hydrophilic and this is hydrophobic. This part is hydrophilic and this part is hydrophobic because it's the fatty acid and it's nonpolar. It doesn't like water. But the problem is there's water outside and inside. So the only solution is to create a structure that looks like this. So that the phosphate faces the water that's outside and the fatty acids are buried inside. This one faces the water that's inside and this guy is buried inside the membrane, away from the water. That's why all membranes are bilayered structures. Why? Because there's water outside and water inside, and the fatty acid tails don't like water. So they're going to do everything in their power to stay away from it. And the only way to do that is to form the structure. It's amazing how that works. All right, so phospholipids are basically the main lipid in your cell membrane. Okay, cholesterol is another example of a lipid. Cholesterol is a precursor for a lot of hormones like estrogen, progesterone. So cholesterol, yes, in high amounts is not good for you. But do you need cholesterol to survive? Oh, you bet. We'll see cholesterol's role in the cell membrane as well. You need cholesterol in your cell membrane, obviously at healthy levels. If your cholesterol is too high in your blood, that's not good for you, and you need to do something about it. But you cannot drop your cholesterol down to zero. That is not good, because cholesterol does a lot of things for you. And we'll see its role in the cell membrane in chapter 7. But it is a lipid. It is a precursor for a lot of steroid hormones. Again,